Hello everyone, my name is Ali Akbar. I am going to explain to you all about the different types, or let's say about the different classifications of IC engine. I will try my best to give you the rough idea about the different types of internal combustion engine. Now, first and foremost, the IC engine, also known as the internal combustion engine, is defined as an engine in which the fuel is burned within the engine cylinder. IC engine can be classified based on basic engine design, working cycle, fuel, method of ignition, method of mixture preparation, valve or port design, combustion chamber design, method of load control, method of cooling, and last but not the least, IC engine can also be defined based on its application. Now, the first category of internal combustion engine, that is basic engine design, is divided into two subcategories. First, reciprocating engine, and second, rotary engines. The different types of reciprocating engines available are: first, inline engines. As shown in figure, the engine cylinders are arranged in a line, thus the name inline engine. Second is V engine. The difference between inline engine and V engine is that in V engine, the engine cylinders are arranged in V shape, as we can see in this figure. This engine design is useful when there is vertical height constraint in engine design. That is, V engine is shorter compared to inline engines. I will explain all of this in more detail in my further classes. Third is radial engine. Unlike inline engine and V engines, the engine cylinders are arranged radially with respect to the camshaft axis. This radial engine was the most common option before turbine engines were introduced. They have been found on everything from crop dusting planes to bomber planes and continue to be used today. Radial engines are ideal for smaller aeroplanes or fleets. Fourth is opposed engines. In this type, the engine cylinders are arranged in opposite direction as shown in figure. This engine is ideal for the race car design as it has very less vertical height compared to our inline engine and V engine. Wankel engine is a type of rotary engine. The main advantage of using this type of engine is that it is generally 30% lighter and produces twice as much power compared to reciprocating engine. But unfortunately, it gives poor fuel economy and have high emissions and unburnt hydrocarbons. Second category is working cycle. Based on the working cycle of an engine, IC engine can further be classified as: first, 4-stroke engine. It is an internal combustion engine in which the piston completes 4 separate strokes while turning a crankshaft, where a stroke is referred to the full travel of the piston along the cylinder in either direction. This 4-stroke engine produces 1 power stroke for every 2 revolutions of the crankshaft. The 4-stroke of engines are: first, induction, where air and fuel mixture is induced inside the cylinder from the intake port, as we can see from the figure. Second, compression, where this air and fuel mixture is compressed. Third, power stroke, where fuel burns and transfers its energy to the piston, which in turn converts this thermal energy into mechanical energy. Fourth, exhaust stroke. The residual gases or burnt gases are removed from the cylinder through the exhaust port during the exhaust stroke. Second category is 2-stroke engine. 2-stroke engine is a type of internal combustion engine which completes a power cycle of a piston during one crankshaft revolution. The end of the combustion stroke and the beginning of the compression stroke happens simultaneously. with the intake and exhaust function occurring at the same time. This I will explain in another classes. Two-stroke engines often have a high power to weight ratio and are more compact and significantly lighter compared to four-stroke engine. Third category is fuel. Based on the type of fuel used, an internal combustion engine can be classified as petrol or gasoline engine, diesel engine, natural gas engine, LPG, alcohol, dual fuel, and hydrogen engine. Fourth is based on method of ignition. Based on method of ignition, an internal combustion engine can be classified as spark ignition engine, that is SI engine, compressed ignition, that is CI engine, and homogeneous charged compression ignition engine, that is HCCI engine. Now, SI engine uses spark plug and CI engine don't. Instead, it uses fuel injector and fuel is injected during the end of compression stroke. This is because the compression ratio of SI engine is small and temperature developed is not high enough to start the combustion, and so spark plug is used to initiate the combustion. Once the initial spark is generated, the flame front takes care of the rest. Whereas in CI engine, the temperature generated is higher than the ignition temperature of diesel due to high compression ratio, and so a spark plug is not needed. SI engine works on Otto cycle, whereas CI engine works on diesel cycle. SI engine uses gasoline, that is petrol, as fuel, and CI engine uses diesel as fuel. Whereas for HCCI engine uses a lean pre-mixed air-fuel mixture. Homogeneous mixture of air and fuel is compressed with a high compression ratio inside the combustion chamber. During the end of compression stroke, ignition occurs through self-ignition in the whole combustion chamber at once, that is instantaneously. Since the mixture used is lean, the maximum temperature both locally and overall becomes low compared to other engines, which effectively reduces the NOx formations. Now, based on the method of mixture preparation, IC engine can also be classified as first, carburation. In carburation, an internal combustion engine, more precisely an SI engine, mixes air and fuel prior to the intake stroke in a device called carburetor. The carburetor works on Bernoulli's principle. It basically consists of an open pipe through which the air passes into the intake manifold of the engine, as we can see over here. The pipe is in the form of venturi. It narrows in sections and then widens again, causing the airflow to increase in speed in the narrowest part. Below the venturi, there is a throttle valve which is used to control the quantity of air and fuel mixture to be delivered to the system. Fuel is introduced into the airstream through small holes at the narrowest part of the venturi and at other places where pressure will be lowered when not running on full throttle. As we can see, the fuel is coming from this direction. Second is fuel injection into the engine cylinder. Fuel injection is the system for introducing fuel into the internal combustion engine. Fuel is transported from the fuel tank and pressurized using fuel pump. This fuel is directly injected inside the cylinder by fuel injector, and air is introduced via the intake port. As we can see, the fuel is injecting over here and air is injected through the intake port. Third is fuel injection into the intake port or intake manifold. In this, the fuel is injected just above the intake port. This system allows, or let's say provides, more time to fuel and air mixture to get mixed homogeneously, as we can see over here in this picture. Based on the valve or port design, the internal combustion engine can be classified as overhead valve. In overhead valve, the intake and exhaust port are located at the top of the cylinder, and in underhead valve, the valves are located as we can see in this way. Third is the rotary valve. A rotary valve is a type of valve in which the rotation of the passage or passages in a transverse plug regulates the flow of liquid or gas through the attached pipes. Other three types of valve or port design are cross scavenge, through or uniflow scavenge, and loop scavenge porting. These are used mainly in two-stroke internal combustion engine. As we can see from figure, the direction of flow after scavenge determines the type of porting. Other type of internal combustion engine classification is based on combustion chamber design. That is either open chamber or divided chamber. Open chamber is a simple chamber which we have seen so far, whereas divided chamber has two or more subsections of combustion chamber, which I will explain in further detail in another video. Based on the method of load control, the internal combustion engine can be classified based on the throttling of fuel and air flow together, so mixture composition is essentially unchanged, similar to carburation process. Second is based on control of fuel flow alone, similar to that of fuel injection technique discussed before. And third is a combination of these. Now, based on the method of cooling, an internal combustion engine can be classified as first water-cooled engine, where water is used as a coolant in order to cool the engine, that is in order to remove heat from the engine. A flowchart for working cycle of water-cooled system is shown in this figure. Water from the radiator, as over here, water from the radiator passes through the engine and carrying heat from the engine parts, and thus again rejecting the heat to the surrounding in the radiator. Second is the air-cooled engine, which doesn't require any sophisticated equipments like water pump, radiator, or any other extra piping. Instead, it uses fins. These metal fins transfer heat from the engine to the surrounding atmosphere, thus keeping the engine cool. The main disadvantage of using this system is that it can be used only in smaller engine because of poor thermal conductivity compared to water-cooled engine. Third is uncooled engine, which doesn't employ any type of cooling method. Last but not the least, the internal combustion engine can also be classified based on its type of application, that is automobile, trucks, locomotives, light aircraft, marines, portable power system, power generation. And that's it for today's class. Thank you very much for your support. Now for the class attendance, please don't forget to hit the like button below so that I can know how many students were present in my class. And please subscribe to this channel and stay connected for the future classes. My next two classes will be on engine operating cycle and IC engine components. Thank you very much for your support. Bye bye. See you all again in my next lecture.